Hello everyone, welcome to this video. In this video we shall be learning about this concept of conjugacy classes. Now let's understand first of all what and how and when can we say a class to be a conjugacy class. What is it? So as for the definition of this conjugacy class, suppose we define this conjugacy class for some element which is a member of some given group G, right? For this, what we do, we select any two elements, say A and B, from the given group G. Then we say that the element A and the element B, they are conjugate to each other in the given group whenever we have x inverse is equal to B, and in that case we call this B as a conjugate of A, right, and A as a conjugate of B, right? And moreover, what is this x? This x could be any member of this G. If this relation is true for any one member x which is a member of G, then we would say A is a conjugate of A or B is a conjugate of A or A is a conjugate of B, right? And moreover, we may define the conjugacy class of this element A. This conjugacy class is nothing but this set CL of A, where what all elements would be there in this conjugacy class? The elements such that the elements which are conjugate to A, they all would be members of this conjugacy class of A. So that means all those members which could be written as some element x into A into x inverse. Now this is multiplication here whenever we have x inverse, right? So we have multiplication here and multiplication here whenever the group operation is multiplication, and we have different group operations here if different group operation is given to us. So taking this in mind, you should consider and understand that conjugacy class of some element A contains all those elements which are conjugate to this element A, right? So this is the conjugacy class of some element A. Now let's understand this definition with the help of an example. So let's move forward. Now we take our favorite example, which is the dihedral group of symmetries of square. It contains the elements, 8 elements that you know pretty well. Now we need to calculate what is the conjugacy class of some element H within it. What we do, we select some element H. Now we wanted to select its conjugacy class it contains which all elements. So what we are going to do, because you know in the conjugacy class we have X, in the conjugacy class of H we have all the elements of this kind where we have x inverse, such that this x is a member of D4 in this case, the group, right? So that means x could be any member of D4. So that means in the conjugacy class we will calculate this relation for every element which is a member of D4. So we know in D4 we have R0, we have R90, we have R180, we have R270, and then H, then we have V, then we have D, and we have D dash. So corresponding to these 8 elements, we would obtain this expression, solve it, and then we will exclude all the values which are repeating themselves, and will be left with the set consisting only of the entries which contain the conjugate, which are in fact the conjugate of this element H. So let's now solve all of these elements one by one. So when we solve this first element here, you know R0H R inverse. So for solving all of these, you know you require the scalar table for the group D4, and you know how to construct it. So here we wanted to calculate what is R0H R0 inverse. So you see R0 into H, R0 is here, H is here, it is H. And what is R0 inverse? So R0 inverse is R0, so the answer is H in this case, right? So the first answer is H. Similarly, we can calculate the second entry also. What is this? The second entry is R90 H R90 inverse. So here we would first like to calculate R90 into H. What is it? Here we have R90, here we have H, so it is D dash, right? D dash into R90 inverse. Now you will be looking for this entry. What is R90 inverse? So you see in the column for 90, where are we getting a R0? R0 is here and we are getting it corresponding to this R270. So that means the inverse of R90 is R270. Why? Because R90 composed with R270 would give you R0, right? Which is the identity of the group. So therefore we have D dash and here we have R270, and when you solve this D dash composition with 270, what do you get? You get V as your answer. So the second entry here, it reduces to D dash R90 inverse, and what is it? It is V, right? Moving forward on to the next entry, we wanted to evaluate this R180 H R180 inverse. So we wanted to calculate R180 H R180 inverse. So let's first calculate R180 into H. R180 is here, H is here, so your answer is V, right? V into R180 inverse. The inverse of R180 corresponds to this R0, which corresponds to this R180. So we have R180 here as the inverse of itself. And what is V into R180? V is here, right? So in this we wanted to look at the entry which corresponds to R180. It is this H. So your final answer is H in this case. So we have V into R180 inverse, which is H. Similarly, we can calculate it for all the elements here. So therefore you can see here, when you simplify all the entries and calculate all the digits here, so you would be getting HV, HV, HHVV. So that means your set, after excluding the entries which are repeating themselves, so we are only left with the set containing H and V. So this forms the conjugacy class for the element H, right? It contains two entries, so H is a conjugate to itself, and moreover H is a conjugate of V, right? Similarly, in this manner, we can calculate the conjugacy class for R0, R90, R180, R270, V, D, D dash, right? So what would be the conjugacy class if you solve for R0? So in this case, the conjugacy class for R0, what is it? It would contain all the elements X such that when we simplify this expression, X into R0 into X inverse, where X is member of D4, we have a conjugacy class. So that means we will be taking X as again R0, R90, R180, R270, right? And H, V, D and D dash, and then we will solve this for this expression. So you have all these 8 entries here. So after solving these 8 entries, the answer that you will be getting each time would be R0 only. So you see, in the conjugacy class of R0, we only have R0 as our answer, right? So R0 is conjugate to itself. In a similar manner, we can calculate the conjugacy class for R90. It has two elements, R90 and R270. You can solve for these using the Cayley table, and you can perform the calculations as I have just told you, right? In that manner. And similarly, the conjugacy class for this R180, it is obtained as R180 only. Next, we can see the conjugacy class for R270. It is R90, R270. So you see, this is same as that of R90. So this conjugacy class and this conjugacy class, they are equivalent, right? And the conjugacy class of V, it contains V and H, and it was the conjugacy class for H. So the conjugacy class of V and that of H, they are the same. Similarly, the conjugacy class for D is D dash. It contains D and the element D dash, and the conjugacy class of the element D dash contains D and D dash. So therefore you have both these conjugacy classes as the equivalent. So do you notice a thing? All these conjugacy class, either they are equivalent to each other, right? Equivalent to each other, or they are disjoint to each other. So in the next video, I'll be taking you forward with these observations and we'll be moving forward on to an important result. Well, that is it for this video. Thank you for watching.